Hi, I'm Jim Leary. I'm a professor at Purdue University, and we're now in the Burke Nanotechnology Center, and what I'm going to talk to you about and show you as a tour of my labs is the use of nanotechnology combining with medicine in a new discipline known as nanomedicine. And this is a revolutionary new way to approach solving human disease one cell at a time, and hopefully long before any of the destructive stages of disease begin. So let's go for a tour of my laboratory, and we'll look and see what this really means. Let's stop at my lab here. This is where we're making a portable blood analyzer device that's about the size of a cell phone. And we're going to be using this to give to astronauts to take up on the space shuttle and space station. And we're also going to bring it into operating rooms with newborn babies are born so we can analyze their blood and try to see if there's any treatment that the babies need immediately after birth. Inside the room, you'll see my student looking at some of the little microchips. And again, these things are about the size of a microscope slide, and they're going to go inside this device. Let's take a tour of the clean room. We can't go inside the clean room because even something as small as a speck of dust is like a boulder to the people who work inside that facility, and much too big for anything that we also work on the devices that we're making for nanomedicine. So we have to keep very, very clean, but we do have a viewing gallery that we can actually go by and look through and see people as they work in this facility. This room, we use light beams to actually make little channels smaller than the width of a human hair that can allow the blood cells to go down those channels and then be counted properly and analyzed for a blood analyzer. The windows here are orange covered because we have to get out all of the stray light that would otherwise destroy the process of making those very, very fine channels. Now let's go inside my lab and I'll show you some really cool technology where we're using laser beams to look at cells streaming past at more than 50,000 cells per second. And we're going to be using this to look at very, very rare cancer cells that are inside blood. The machine I'm going to show you is a flow cytometer cell sorter. And basically this is a machine that's kind of like a microscope, except instead of putting cells on a slide, we actually shoot them past a laser beam at very, very high speeds. And we can look at them one at a time. And that's very important because when we do nanomedicine, we're actually trying to do single cell medicine. So to do that with the trillions of cells that you have in your body, we have to examine them very, very fast if we're going to find, for example, cancer cells circulating around inside a person's body. So let's go inside and see what my graduate student, Mike Zordon, is doing. One of the things we're doing with Mike's research is we're finding those very rare cancer cells, and we're finding how to target our little nano devices to those rare cells. And that will allow us to be able to put very, very tiny medicines inside the human body to go around the human body and find those very rare cells and cure them at a very early age. So instead of taking one pill in the morning like you do your vitamin pill, we would have put in billions of little tiny pills that would then circulate around the body and find the cancer cells and search and destroy those in ways so that people don't have to undergo the very painful chemotherapy that many of you may know from members in your family and friends. So this will allow us to treat the disease at a very early stage and to have a very high success level in being able to cure cancer and other diseases.